Hey there, everyone. My name is Ryan Schul. Welcome to my data science channel. So on the project today, I want to talk about stock price divergence and convergence for highly correlated and highly co-integrated stocks. So basically, what does this mean? So if McDonald's and Burger King are pretty similar, and we know they are, Microsoft and Apple are pretty similar, we know they are. If these stock prices diverge, one's going up and one's going down, eventually, if the businesses are essentially similar, have similar profits, similar sales and things like this. If the businesses are fundamentally similar and one's going up and one's going down, there must be a temporary reason for that. There's some kind of price dislocation in the market. And these two, although they are diverging, one's going up, one's going down, they have to converge at some point. They're going to meet up again in the middle because the stock that's going down is going to become cheaper and cheaper. People are going to recognize that and they're going to buy it and push it up. And one that's climbing up, eventually people are going to say, this thing is too expensive. I'm getting out, I'm dumping shares, and the price is going to go down, right? So that's the whole theory here. We're going to dive in and see if we can prove this and understand the theory and see if we can prove the outcome, right? So this creates market neutral strategies, right? Hedging our assets, creating opportunities for capital gains, pairs trading. That's what this thing is called. That's the nickname for this. And it bets that the spread between the historically correlated stocks, if they're highly correlated and co-integrated and they move together, typically they diverge, right? One goes up, one goes down. They're going to converge at some point. So this exploits temporary inefficiencies in the market, almost like a, what's it called? Not an anomaly, oh my God, I forgot the name. Sorry. Arbitrage, almost like an arbitrage. It's not real arbitrage, right? But there's almost like an opportunity to exploit the inefficiencies in the market here, right? This is quantitatively based and rule based as well. This is used by hedge funds and prop trading desks. There's not as much prop trading done these days as there was, a couple decades ago. That was pretty popular, but it's still done. Not big banks. There's so much compliance and regulation around that. Not too much, but definitely at smaller independent outfits. Convergence is predictable. Divergence is predictable as well, right? So we can exploit these opportunities. And low correlations with trend following strategies is easy to understand and explain to other people, right? So you can get buy-in for your shareholders and from your investors. So I'm going to go ahead and import our historical stock price information here. This is very easy. If you've seen a few of my videos, I do this all the time. Go into Yahoo Finance, right? This is the API endpoint and pull in this data right now. We're going back 1 year in time. That's sufficient. That's all we need. And this is the start date, and the end date is actually today. And the start date comes from today minus 1 year ago. So we have the start, we have the end. It's pretty dynamic. We pulled in the information here and we calculated the correlation. So we're looking at the correlations, right? We have to look at the correlations between these stocks. Correlations mean if one thing, it doesn't even have to be a stock. If things are correlated, one thing happens and it moves in a certain direction, and another thing moves in the same direction at the same rate, the same pace, at the same momentum, then those are correlated, right? If one thing moves up and one thing moves down, then they're negatively correlated, right? So there's positive correlations and there's negative correlations. So that's how this works, okay? So we're going to look for correlated pairs and look for chances of finding spurious correlation. So it could be a correlation, right? But the correlation might be might not have really any real value, right? So in the summertime, more people buy ice cream, more people go to the beach and go swimming, and there could be an increase in shark attacks at the beach. But does the probability, I guess, of buying ice cream increase shark attacks? No, there's a high correlation between ice cream sales and shark attacks in the summertime, but there's no incidence or like cause and effect between those two. They're totally independent, right? So we're looking at the correlations and looking at the pairs, but we also have to find the co-integrations between these pairs, okay? So I can go ahead and refresh this right here and put together this little matrix right here. So correlation greater than 0.9, very strong, excellent for co-integration filtering. Greater than 0.75, strong correlation, safe for testing. 0.5, moderate correlation, may include noisy pairs. That's what I was talking about with the ice creams and the sharks, right? No real cause and effect there. 0.3, weak correlation, likely too low to make a profit from, probably meaningless. It's basically useless. Less than 3, there's no correlation, not worth testing. Okay, so now let's look for co-integrated pairs here and plot the results. If we find any, we set up signals and we're looking for z-scores. So z-score is basically the spread, the average of the spread, and we're dividing by the standard deviation, right? If you want to look for a z-score, you can go ahead and Google it. I've got several videos that explains how this works. Z-score. You can just Google that, right? So it's a way of standardizing everything so you can compare everything to everything in the whole universe. I just put out a couple of videos recently about how this works. So it's the item minus the average of all the items divided by the standard deviation, right? So we take that and just, it helps us standardize everything and compare everything relative to everything else. So I just ran that. So we have the plot over here, and you can see the time series from 2024-07. We're going back in time 1 year. Now it is July 18th, 2025, right? So we go back to last year, July, to start the analysis. We can see the z-scores over here in the spreads, and this we actually found one. So we found one instance of correlation and co-integration, right? So we're looking at PG, Procter & Gamble, and KO. This is Coca-Cola. So the stock pair that we just found is Procter & Gamble and Coca-Cola. This correlation is 0.52. It's moderate correlation, or 0.592, almost 0.6 moderate correlation. Not super strong, but it will illustrate the point here. I set this correlation over here a little bit higher. Now, where is it? I think it was in the previous step. I set this to 0.7. Really, you want this like 0.7, 0.8, 0.9 ideally. But if you go that high, I didn't find any. You can put in different stocks, right? I'm just looking at the Dow 30 here. You can try this with the S&P 500. You can put in the Russell 2000, right? So you can put in whatever stocks you want. You can go back in time for a longer duration. I went back 1 year. That's it. So I'm just trying to illustrate the point of how this thing works, but you can go ahead and reset those variables to anything you want. The co-integration p-value is 0.0338. So this is significant at the 5% level. Again, we're a little bit low, but if I set these thresholds too high, we would have nothing to work with. So I'm a big fan of let's have something, let's produce something. I've worked on teams where they'll work for 6 months, 9 months, a year. Nothing gets done. There's no proof of concept, nothing happened. You look back in time, well, what did we do for the last year? Like nothing happened. I hate that. Okay. Let's just get something done and have a minimum viable product, MVP, minimum POC, proof of concept, just get something done and something on the table, some kind of deliverable, so we can make a presentation and talk to our stakeholders, right? If you come up with nothing after 1 year, there's really no excuse for that. I wasn't a team lead on that, thank God. But these things happen, right? But I'm a big fan of just making something happen and getting something done rather than nothing. Something's better than nothing. Average convergence when z-score deviates z greater than 1, it takes about 16.25 days on average to converge and go back to z less than 0.05. Okay, the number of divergences in the cycle is about 8 per year. These are all the z-scores right here, so we can print these out. Okay, and again, we're looking for z-scores probably greater than 1.0 or less than 1.0. So let's go down here and compute the actual spread and the z-score. Okay, so we know the tickers. I just put these in. I hard-coded it. You can actually pick that up from over here because we know stock 1 and stock 2. In this case, it's very straightforward. It's very simple. So I just plug that in right there. So again, we're looking for signals and the entry price and then the exit price. That's the goal right here. Okay, and we're going to append everything to durations. So if I do Control-C, Control-F, you can see durations append date minus entry date in terms of days. So I'm appending everything to this list. In the Python world, anything with square brackets is a list. Anything with curly brackets, if you have the squiggle brackets, that is a dictionary with p-value pairs. And if you have the kind of like nice curly brackets, that is a tuple, right? So we're using a list here and we're doing an append into the list. And the final outcome here is the average convergence time is about 23.25 days on average when there's a divergence, and it's going to converge in about 23.5 days, so close to a month. Total profits from this pair trade is $5,720. Number of trades is 9, and the average profit per trade is $635. So I went ahead and plotted this in a plotly chart down here. Whoops, I'm not sure what happened to the plot. I just ran this before. I think as I put in more days, I think it got a little bit wackadoodle there. But it was supposed to go up to, let me fix this, 2578. I'll fix this thing, 2578, because that number right here, if I zoom in, 2578 matches this. 5720. I'm sorry, I just ran this before. I'm not sure what happened here, but let me go back and fix this up, because I was running right before I added in the average convergence number of days. I'll fix that up when I send out the video later. But basically, we're stepping into pairs trading execution based on the mean reversion using a z-score spread between PG and KO, so Procter & Gamble and Coca-Cola, kind of the same types of businesses, right? And remember, if the z-score is greater than 1, the spread is wide. So you short Procter & Gamble and you buy Coca-Cola. If the z-score is less than -1, then the spread is wide, and you go the other way. You go long Procter & Gamble, you buy Procter & Gamble, and you short KO, okay? And the z-score total profit, and you can see over here, is 5720, okay? And the average convergence time is 23.25 days. So I don't know what happened to that chart. It got a little wackadoodle at the end. I'll fix that up. I'll look into that. I don't want to waste a lot of your time. And I honestly don't know how to do edits in these things. One of these days I have to learn how to do an edit. You cut it, and then you make whatever you have to make, and then you append the edit to that thing. I'm not sure how to do that. Like, my background is not video editing by any means. But let me look into that. I'll fix it up. That's it. I'm going to wrap it up here. I'll share the code after I fix it up. I promise to fix it. So when you get it, it's going to be nice and clean. Everything will work perfect. Thank you so much for your time today. Appreciate that. Enjoy the rest of your day, and I'll see you soon when I put up the next video. Take care. Bye.